Next, let's cover multivariate volatility modeling. This is advanced topic, so we will just go through the material without Python coding. See chapter 10 of the textbook, very good textbook. Study time evolution of actually covariance matrix. Okay, here because it's covariance matrix, therefore sigma t is symmetric. Sigma 1 2 at t, sigma 2 1 at t should be same. There are three variable, this one, because it's 2 by 2 matrix, 4 and the symmetric, so 3 variable. For k as the return, k by k, including time matrix, so it should be k plus 1 over 2 variables. Requirement. Okay, this one, sigma t covariance matrix must be positive definite for all t. So diagonal terms, they are variance, so diagonal terms should be greater than 0 and the determinant should be positive. The time varying correlation between R1t and R2t looks like this. Now there are some complications. Well, the positive requirement, variance is positive, so in terms of covariance matrix, it is matrix, so defining positivity or negativity of matrix of it not exactly same but related. Okay, it should be a bit nuanced. So when we say something positive about or negative of matrix, instead of saying positive or negative, we say it is positive definiteness or negative definiteness. Anyway, because it's correlation covariance matrix is somehow it is similar to positive, so it's a positiveness requirement is not need to meet in uh, time varying volatility process covariance matrices. And then there are maybe too many series to consider. Some simple models are available to get over those challenges. Exponentially varying covariance or use univariate approach like covariance xy is something like this one, and we estimate just variance, or back model, BEKK model, very popular one, and my favorite, dynamic conditional correlation model, DCC models. First, exponential weighted model. It is sigma t is modeled weighted average of this term and this term, weighted average by weighted by lambda, where lambda is between 0 and 1. That is sigma t is, in some sense we can rewrite this one is this one. Okay, r command, there is r command about this. The bank model of angle and corner, very famous model. Simple back 1 model is sigma t is some a matrix a0, which is lower triangular matrix a0 prime and a1, and then this one. Okay, yeah, prime, and then we have some iterative relationship. Okay, where A is lower triangle matrix, A1, B1 are square matrix without any restriction. Okay, it satisfies, it is positive definite because of this one and this one and this one. Okay, they are all cross multiplied. There are some drawbacks, there are cons, many parameters, there are simply too many parameters, and dynamic will require further study. Estimation back 1 commented MTS package can be used for k equal 2 or 3 only. If k is large, it is computationally too heavy. DCC models a two-step process. You use two-step process. First was a marginal model. Use univariate volatility model for individual return series. Okay, individually. Now, next, we use DCC model for the time evolution of conditional correlation. How to do that? Specifically, the volatility matrix can be rewritten as this covariance matrix, and then with VT, RT, VT. VT is the diagonal method volatility for individual return. We can use like a GARCH for individual series and fill the diagonal element of this matrix with that term. Now the only remaining part is RT, which is correlation, conditional correlation matrix. That is, it is the something like this. So we estimate this one with Garch, for example, and then we can only care about this one correlation, time varying correlation matrix. Two types of DCC are available in the literature. Angle version is QT is this one, like this, and RT is then using small qt inverse qt. Small qt is basically this one, only diagonal term of qt. Okay, and RG is sample, just a sample correlation matrix. And another very popular one is this one, 1 minus theta 1 theta 2 R naught. Again, this is sample correlation matrix, and then theta 1 R T minus 1. So we use recursive relationship, and then sum this part where we have restriction. Okay, and then this is here now. This is sample correlation matrix, and it is starting point. Okay, sample correlation matrix of this one for pre-specified positive integer m. Okay. Discussion. This is a model is extremely simple with only two parameters. On the other hand, model checking tends to reject the DCC model. DCC model is simple, but when in reality it does not well satisfy the data, explain the data. Our comment of the MTS package for DCC modeling is DCC purely fit individual Cauchy model, standard return series is including the output, and DCC fit estimate DCC model for the standard return series, and the MCH diagonal model checking of multivariate volatility model. If time permit, demonstration will be given in the class. Okay, it is advanced topic, so I'll skip this part.